Let us now see another application of these linear equations in engineering, where we will discuss how an object of uniform properties expands when we apply a load to it. Our object will be a cylindrical object. So a cylinder has a circular cross-section. It will have a length, let's call it uppercase L. Let's call the diameter D. And on this object, we will apply a force, F. When we apply this force, what happens to the object? When we apply this force, this object will expand axially along the direction of the force, and then it will contract diametrically in order to conserve its volume. So the object now changes in size. And we are going to exaggerate here in order to demonstrate this idea. So here I exaggerated this component here on the left-hand side, let's call it alpha, will be the same as this component here called alpha. So the total of these, of 2 alpha, will be the total change in length. And of course, we said that the diameter will also change, so it will be, let's say, lowercase d. So the initial length was L, and the final length is L plus 2 alpha, or L plus delta L. The stress that is generated on this object is the force divided by the uniform cross-sectional area. So we call this stress is equal to the force divided by the area. Another quantity that we have in engineering is called strain. And strain is given as the stress divided by the Young modulus. The Young modulus is, or modulus of elasticity, is a material property. Modulus of elasticity. So every material has its own modulus of elasticity. Also, strain is defined as the change in length divided by the original length. And if we combine these equations now, the equation for stress, the equation for strain, we can solve for the amount of elongation that will take place. So I will leave it as an exercise for you to combine these equations and solve for delta L. Delta L will be equal to L times epsilon. And if we perform the algebra of substituting these expressions, we end up with the following expression. F over AE divided again by L. So this is an nested fraction, and we can write it as F times L divided by A times E. So this will allow us to find out the elongation when a known force is applied to a known geometry. As I mentioned earlier, the diameter will also change. So if we wanted to find out how much the diameter will change, what we need to do is to perform a volume conservation analysis. Find the initial volume and equate it with the final volume. And we can solve for the unknown final diameter d.